Today we're going to look at lesson 20, and your I can statement or learning objective is I can simplify square roots with I. This is the same as what we did yesterday, but with an extra step. And the extra step is actually pretty easy. So hopefully this assignment will be really easy. You'll catch on really quickly because most of what we're doing is the exact same as yesterday's work. So as usual, I'll be going through this a little bit faster than I would if we were in person. So feel free to pause, rewind, whatever you need to. Okay. So since we're using this I, we need to talk about it. We're going to talk about imaginary numbers. So far, we've just talked about real numbers. Okay. But there is a such thing as an imaginary number. We get imaginary numbers from square roots of negatives. You cannot take the square root of a negative number, because a square root means what number times itself gives us the number inside. Well, it's impossible to do a number times itself and get a negative number, because to get a negative, you have to have a positive and a negative. So you can never do, like, for example, 1 times itself is 1 times 1, and that gives us 1. If you have -1 times -1, that's -1 times itself, and that also equals a +1. So it's impossible to have that negative number inside. And since it's impossible, we can't use our regular numbers, we use imaginary numbers. So the I is equal to the square root of -1. Okay, and sometimes you'll see an I like this, sometimes you'll see it as cursive, but it is a lowercase I. So we're going to practice simplifying square roots that have a negative inside, and we get rid of the negative by using I. So let me show you what I mean. So if we have, let's do something simple. Let's say we have the square root of -25. We have a negative in there. We know that it's impossible to take the square root of a negative number. So we can break this up to the square root of -1 times the square root of 25. We know the square root of -1 is I. We know that the square root of 25 is 5. Okay, now I times 5, that doesn't look great, so we're going to change that to 5I, so 5 times I. Okay, so that's how it works. Now, we're not going to write it out like this every single time. We're going to get to where we can go straight from here to here. Okay, but this is how it works. Okay, let's look at these 3 examples. So 36, 181, those are all perfect squares. So we're just going to practice those when they have a negative. So we take out the negative by creating an I. And what's the square root of 36? 6. Now, we don't leave it as I times 6. We change it to 6I. All right, what about the square root of -100? What's the square root of 100? 10. How do I get rid of that negative? With an I. All right, what about the square root of -81? What do we think? 9I. Okay, so we're doing that same thing. We did that yesterday. We're going to do it again today. We're also going to simplify non-perfect squares. So you're going to have to use factor out your perfect squares, or use a factor tree. But it's the same as what we did yesterday. Okay, so let's look at these examples. So we have the square root of -80. So I know I'm going to have an I, so I'll go ahead and do that. And now let's do a factor tree of 80. So I know 80 is 8 times 10. 8 breaks up into 2 times 4, and 4 is 2 times 2. All right, so look for my pair. Oh, and 10 is 2 times 5. All right, so I have a pair of 2's here. I have another pair of 2's, so that's 2 times 2. And I have a 5 left over, so I put a 5 in parentheses, or in the radical. All right, so now I've got to take care of this stuff out front. So I'm going to do the 2 times 2 is 4. I'm going to put the I behind it and bring down a 5, or the radical of 5. So my final answer is 4I square root of 5. Okay? Number 5, I have the square root of -75. Now, I know that a perfect square goes into 75. I know that it's 25. So I'm going to go ahead and bring out the I, and I'm going to change this to the square root of 25 times the square root of 3. I know the square root of 25 is 5. I'm going to go ahead and put my I behind it, and I have the square root of 3. Okay, so there's your two ways. Remember, you can do the factor tree, or you can break it, find the perfect square and break it up into two smaller radicals. Either way works. All right, number 6. I'm going to do a factor tree of 20. It's 2 times 10. 10 is 2 times 5. I have a pair of 2's, so I'm going to bring out the 2. I'm going to bring out the negative and create an I, and then I have a 5 left over, so 2I square root of 5. All right, number 7, I have the square root of negative 104. So I know it's a negative, so I'm pulling out the I. And it doesn't matter. I did it first on some of these. I saved it on some of them. It doesn't matter as long as you pull out the I and get rid of the negative, okay? Because when you pull out that's the only way to get rid of that negative on the inside. Okay, so if I'm looking at 104, I'm going to divide by 4. Let's see, what's 104 divided by 4? 26. So 4 times 26, I know 4 is 2 times 2. 26 is 2 times 13. 13 can only be 1 and 13, so I'll leave it. I have a pair of 2's. Okay, so I'm going to put a 2 out in front of the I, and I'm left with 2 times 13, which is 26. All right, number 8, I have negative 99. So I'm going to take that 99. See, 9 times 11. 9 can break up into 3 times 3. 11, it's just 1 times 11, so it can stay. All right, so I know I have an I because it's negative. I have a pair of 3's, so 3 goes in front. And then I have 11 inside. 11 has to stay because it doesn't have a pair. All right, and my last one, all right, I'm going to take the 48. I know that can be 6 times 8. 6 is 3 times 2. 8 is 4 times 2. And 4 is 2 times 2. So I have a pair of 2's here and another pair here. So that's 2 times 2. Bring down the I. And then I have a 3 left over. Is that right? So 2 times 2 is 4. And I bring down my I and radical of 3. So 4I square root of 3. Okay, now, I know that we just did 9 examples, but you're doing the same thing that you did yesterday. The only thing different is you have an I. So you get rid of that negative under the radical by bringing out an I. So your problems in Math Excel are very, very similar to these. I think you might have one problem where it just asks for the square roots of a perfect square like it did yesterday. But these problems should look just like your ones on Math Excel. As always, if you need help, let me know. Hit the Ask My Instructor button, talk to me in the Google Meet, whatever. Okay, whatever you need. But as always, have a great rest of the day.